All right, good morning, good afternoon, good evening, wherever you're at. I hope you're doing great. Just going to go over the homework assignment from last night to make sure that everybody is good with that. Let me get things going here real quick. So looking at number 48, the big thing with these type of problems, like I've been stressing the last couple of days, is to understand what type of shape you're working with. And so in number 48, looking at that, I hope that we all recognize that that's going to end up being a rectangle if it's a parallelogram. And so I know that the diagonals are congruent in the rectangle. Now, hold on one second here. Sorry, I thought it was, should be there. There we go. Okay. Let's, there we go. Okay. So if I go ahead and take a look at this, sorry about that. I have SW, this length right here, and I have RZ, which is this length right here. Now, obviously, you'd like to set those two equal to each other, but they're not equal. Okay, the length of SW isn't equal to the length of RZ. And so the next thing I want to do is understand that the diagonals of a rectangle or any parallelogram bisect each other. So those two lengths are the same. And since this length is equal to this length, if I double RZ, that will equal SW. Okay? And so we have two equal lengths there, and you can go ahead and solve for x from there. For number 49, if we take a look at this one, the question again is, what type of figure is this? Well, if it's a parallelogram, the opposite sides have to be congruent, so I'm going to mark those out. So I at least know I have a rhombus. And if these sides are parallel to each other, that would make this right angle and this a right angle. And if these sides are parallel to each other, that would make those two right angles. Okay? And if that's a right angle and these lines are parallel, this would be a right angle. So not only is it a rhombus, it's a rectangle as well. And so in the end, it's actually a square. Now, the key here, folks, is going to be this. Understanding most of the diagonals of the rhombus. The diagonals of a rhombus are perpendicular. So if I go ahead and draw that in, I know that angle 1 has to equal 90 degrees. So that's how I come up with the equation to solve for y. I also know that the diagonals of a rhombus bisect these angles here. And so what we see is that we've got this 90-degree angle that's been bisected, which means that 6z is going to be 45. Okay? We also see that we have this 90-degree angle bisected, so 9x is equal to 45. So again, you've got everything there that you need. You just have to make sure you understand all the little details, the little characteristics that are taking place within that structure right there. Okay? All right, now, the next thing I'd like to do is work on number 50 with you. Now, number 50 is similar to a problem that you are going to see on your chapter test, okay? And so it's really important that you know how to set all the equations up and know how to solve them. So, if we take a look at number 50, the question still becomes, what type of shape is it going to be? Well, I know, again, that this shape is not only a rhombus, being a parallelogram, the opposite sides are congruent, but it's also a rectangle. Therefore, it's a square, okay? And so, being a square, which is a parallelogram, the diagonals bisect each other. So that will be one of my equations I'm going to be working with. The 2x minus 1 is equal to 3y plus 5, okay? One of my equations I need to use. The other equation is this. If this is a square, which is also a rectangle, trying to highlight the four right angles for you, that means that the diagonals have to be the same length. And if that's the case, then I'm going to go ahead and take the sum of 2x minus 1 and 3y plus 5 and set that equal to the entire length of BD, 4x minus y plus 1. Now, now that you have the two equations, hopefully things will get a little bit easier, but what I would do first is I would simplify, especially that second equation. There's just too much going on there, too much to look at, okay? What I would probably do is I'd subtract 2x from both sides. I would add y to both sides. And then if we do this, 5 minus 1 is 4. And if I subtract one more, bringing over that 1, I get 3. So we end up with that as the expression right there. That seems a lot more cleaner than the previous problem. Okay. Now, I'm going to do a little trick here, and some of you may go ahead and solve for x. You can go ahead and solve for x here and then substitute it in up there. But what if we were to do this? If I go ahead and add 1 to both sides, and I get 2x equals 3y plus 6, and now I say, hey, if both of these are equal to 2x, then I could take one of these expressions on the other side and plug it in for the 2x, right? Okay? So I can do a real simple equation here, just like that, okay? All right, so hopefully that made sense to you. I can use substitution that way too. From there, I can subtract 3y from both sides, and I can subtract 3 from both sides, and now I've got the value of y, okay? Now, to get x, I can always plug this back in, and here's what we'll have. 4 times 3 plus 3 is equal to 2x. You could also plug it into this equation up here, but I'm just going to do it in that one, which would be 12 plus 3, would be 15, equals 2x, and then divide by 2, 7.5, okay? That is the x and y value. Now, if you ever want to double check yourself on this, you can always go back here and plug it back in. For example, if I plug in 3, I get 6 minus 1, which is 5. Plug in 7.5, ooh, that's going to challenge me a bit. 24, what did I do? Oh, I see what I did wrong. Here's what I did wrong. The y goes with the y. 3 times 3 is 9, plus 5 is going to be 9 plus 5, 14. Okay. And then if I plug in the 7.5, 2 times 7.5 is 15 minus 1, also 14. Okay. Now, if I plug the x and y into this expression up here, this length should be 28, right? So if I do that, 4 times 7.5 is going to give me 30, minus 3, that would be 27, plus 1, 28. And now we've done it correctly because everything works out the way it should. Okay? So I know that was a big, long explanation. It took a little while, but it is important to know how to do that type of problem there. Now, let's see if I can go over to the other page. All right. So we had 24 and 27 from page 323. Okay? I'm going to talk about 27 first. This one, again, is really important that you know how to do. One that can throw people off on the tests. So when I have the diagonals within a figure, either a rhombus or a kite, it's really important that I show that the intersection forms a 90-degree angle. So I'm going to go ahead and do that right here. Okay? Once I've done that, it's pretty clear that I can set up an equation using these 3 angles right there. Okay? And so my equation to solve for x in 27 should be 2x plus x plus 6 plus 90 equals 180. Okay? Now, from there, obviously you can go ahead and solve for x. I'm not too worried about the algebra. I think you guys are doing a nice job with the algebra, so I'm going to leave that be. You can do it on your own. The big thing is this, folks. Not all of the expressions are beneficial for our equation, okay? And so that had nothing to do with the equation. The right angle, again, make sure you put that in with any rhombus or kite there, okay? Now, there is one more problem on this page, number 24, and here's what we have. I believe in 24, these are all isosceles trapezoids, yeah. We see that up here. They're all isosceles trapezoids. So what do we know about the diagonals of an isosceles trapezoid? Well, I hope that you can tell that those are the same lengths to each other. So we can set their expressions equal to each other. So it should be x plus 1 equals 2x minus 3. And now you can go ahead and solve for x. Okay? All right, now moving on to the last page, what we did yesterday. Oh, yeah. Okay. Last page we had numbers 1 through 4. I honestly think that you should be able to get numbers 1 through 3 pretty easily, okay? And so, give me 1 second here. Okay, sorry about that. Actually, Mr. Knable was walking around, our new superintendent, and saw me waving my arms around and thought they should come in and check on what's going on. So anyways, back to the homework here. Number 1, we want to figure out the ordered pairs of both Z and W. In order to get to Z, we need to make sure that we understand what this means right here, B comma H. And what that means is that this length here is a length of B. This length here is a length of H. Oh, I didn't mean to make a B there. Is a length of H. And so Z being B units from 0, this length here is B, is going to be B comma 0. Okay, the Y value is 0. I'm not going up or down on that. This length transferred over here because it's a rectangle is going to be a length of H as well. So W is going to be 0. The X value is 0. We're not going left or right at all. We're just going straight up, comma H. Okay. For number 2, the key is that this is a square. Okay. Without that understanding, we can't finish out this problem. So I know that this length here is the length of A, the Y value. Okay. That would make this length the length of A and this the length of A. Length of A. So Z is how many units from 0? It's A units. So I'm going to do A comma 0. I'm not going up or down. It's just right there. To get to W, I'm going to go over A and up A. So it's going to be A comma A. Okay. For number 3, this is a square that's being centered at the origin right here. And so this is the length of B, and this is the length of B, over B and up B. That's how I get the X and Y values there. To get to this point right here, I'm going to go over B and down B, negative B. Okay? And so this is equal but on the opposite side. So if this is B, then this is negative B. Obviously, if this length is B, we remain the same. And so the ordered pair for W should be negative B, positive B. And the ordered pair for Z is going to be negative B. Oh, I forgot to put the negative B over here. Okay. Negative B, negative B. All right. So again, hopefully those first 3 were pretty understandable, straight up and down, vertical, horizontal. Those are easier. The slanted ones are a little bit more difficult. And so I'm going to start with this ordered pair right here. And what that tells me is that this point is C units from the origin. So I'm going to go ahead and put this down. Maybe. There you go. That's C units from the origin. Okay. Now, in order to get to this point right here, I know that this value right there gives me how far off the x-axis it is. So if I go ahead and draw this line down, that's a length of B. Okay. So I can actually transfer that length over here. And so W, the X value is 0, the Y value is B. Okay? So 0B is the ordered pair for W. Now, the Z value is a little more tricky. And here's what I want you to see. This X value tells me this. From the origin, I'm going out C units and coming back A units. That's how we get the C minus A. Go out C units, come back A units. So this is A units right here. Okay? Now, if I transfer that over to my other triangle here, I've got A right there, so Z is actually A comma 0. All right? So with these slanted shapes, okay, these shapes that have diagonals or lines that aren't straight up and down, left and right, you're going to have to get a little creative. You have to figure out what the up and down and left and right are going to be based off what's already given to you. If you can do that, you're going to be in good shape. So you'll want to take a look at today's lesson if you haven't already got a chance to see it, and then go from there. So good luck and good night.